I would like you all to welcome on stage Aarathy, who is going to talk about DevTools and how you can use the power of React DevTools and AI. So can we have a huge round of applause for Aarathy on stage? Everyone, this is Aarathy's first conference talk, so we'll need a huge round of applause, everyone. Over to you, Aarathy.
Hello. Yeah. Am I audible? Okay. Yeah. So, good morning, everyone. I hope you all had a great time yesterday. So, my name is Aarathy Muraleedharan. At least some of you might feel a bit difficulty to pronounce my name. So, let's keep it short. So, it's Aarathy. And I'm coming from Keyvalue Software Systems. So, like most of you guys, I'm a software developer who's currently working as an associate technical lead. Oh, God. Associate technical lead. So in Keyvalue, we are basically a product engineering team who's helping startups and scale-ups to build their product from scratch with cutting-edge technologies and AI-first mindset. And till now, we have delivered more than 130 projects for over 90 customers, and more than 40 of them were able to secure Series A funding. So that's regarding me and my company. Yeah, thank you for that. So okay, so let's just get to the topic of discussion. So today in this session, I would like to explore a space that we developers, or rather, we front-end developers spend a lot of time in, which is debugging React applications. So let's see, when we combine this React DevTools with AI, how can we create a fundamentally smarter debugging workflow? So how many of you guys, those who are here, works with React DevTools on a daily basis? And it will be a stupid question to ask, but how many of you are working with AI on a daily basis? So what are the different things that you work with? I mean, what are the different scenarios in which you apply AI while you're developing your application? Some answers can I get? Okay, unit test, I'm hearing unit test. Then actually we use it for code suggestions or code refactoring. So yeah, documentation, actually, that was a major headache. We use it for that. Actually, we can make use of AI in debugging as well. So how let's experiment when we combine this AI and DevTools, what powerful thing will emerge out of it? Let's see. You might feel like, why exactly do we need to merge it? Because the DevTools that we have right now is extremely powerful. They are giving us a lot of features. They are giving us tools to identify or get a better visibility of the bug, and also to do performance profiling of our application. We are having tools for that. But before jumping into any conclusion, let's just see some numbers, okay? Yeah. So an average developer week is, sorry. Let's go back. Yeah. So an average developer week is about 40 hours. We work for at least 5 days a week and at least 8 hours. It's more than that, obviously it's more than that at almost all the time. But average is about 40 hours. So I'm just going to keep about 15% of that total time for debugging. And anyone who spend more than 15%, which is 6 hours, more than 6 hours on a weekly basis just for debugging, just for tracking some production bugs that we got. Anyone? So what was the maximum time that you had to spend? 2 days, just for one bug, okay? So I'll just categorize what we use that time for. So initially, the first thing is to understand the bug. At times, we won't be able to identify what the bug is or where exactly we're getting the bug. So that eats most of the time out of that 6 hours, or whatever time that we are taking. The next is understanding the root cause. Just by getting a visibility, we won't be identifying where exactly that bug originates. And once we finalize on the fix, we have to make sure our app is working perfectly fine, or the performance is not at all affected because of our fix. So we do a performance profiling. So coming back to that time that we spent. So I'm still going to go with that 6 hours. But on a long run, if we consider over an year, it's actually 312 hours that we are spending just for interpreting this debugging data. So 312 hours. It's basically 8 weeks of our developer effort, or rather 2 months of our developer effort. It's a lost productivity just because we are not using the correct tools. Okay, and at least some of you might think, why exactly are we checking these time management thing now? Before going to that, can anyone tell me when exactly React was first introduced to us, or what was the year? Bit close. Yes, so we got our initial version, which is 0.3 in 2013. At that time, it was typically class components. I believe at least some of you have worked in class components. Even though the syntax in which we have to write these components is a bit tricky, or I would say a bit headache, still the component tree structure and all the rendering phases was pretty simple. So we started with simple components. Then 2018, we got suspense. So with the help of suspense, we were able to mark these asynchronous boundaries like loading phases or error scenarios. So whenever we want a fallback, we were able to achieve it quickly or very easily. And then came hooks. That was 2019, which was a major breakthrough. We were able to completely migrate from class components to functional components because of state management. Then in 2022, we got concurrent mode. So till then, the rendering phase was completely linear. But after concurrent mode, the React would start a render phase, it can pause in between, it can stop it, or it can replay the render. All those came into picture. So asynchronous rendering came into picture. And later, in 2024, server-side components came. So all these things, when we got all these features, it's true that now it's easy for us to create an application on a larger scale, or we can include more features into our application. But the complexities and challenges that we have to face while debugging such applications also increase. So let's see what are the complications that we are facing. To understand that, okay. Yeah, so basically, modern React is not simple React. Sorry, I missed that. Then to understand, what happened? Okay. So yeah, so to understand the complexity, I'm dissecting a simple component here. So this is a simple representation of a component. I'm saying I'm having a component with more than 10 hooks. 10 might feel like a large number, but thinking about it, I'm having 3 states, 2 use effects, some hooks like memos or context, or there might be custom hooks as well. And I'm having an asynchronous component. It's the concurrent mode that we are rendering this. Then I'm enclosing my whole component in error boundaries, suspense boundaries. So all these in picture, we have to deal with a lot of debugging challenges. As I mentioned, concurrent mode is one of them. Then with suspense in picture, we have to make sure that suspense that got marked is as expected. Then with hydration. So in server-side components, DevTools actually had to make sure that there is no mismatch between the server render and the client hydration. React DevTools actually helps us to identify all these things, but the problem is the time taken to do that is actually very big. So before going further, I would like to give a small update or small insight about what exactly we are looking at when we check React DevTools. So can someone tell me what exactly we are seeing here? What is this? Yeah, it's an array list, but in technical terms, what exactly are we seeing? It's a DOM. It's a component tree that we're seeing. So actually, in effect, we are not directly viewing the React component tree. It's the fiber nodes that we are seeing here. So basically, fiber nodes is an internal data structure that React keeps so that it can track all those props, states, context, hooks, and what else? Re-rendering priorities, and all those things can be tracked. So since we are getting a visibility of all those fiber nodes, we are also able to see these props, states, hooks, context, and all those values with the help of React DevTools. And then coming towards the features that they're providing. Yes. So the initial first feature is we can actually update a state value or a prop value inside DevTools itself. So it helps us to recreate a edge case without even touching the code base. The next one is we get a proper visibility of the hooks. So we can actually make use of the predefined hooks that React provides us, and also we can create custom hooks. But because of hooks misuse, actually we might be getting some re-rendering issues. So since we are getting a proper analysis or proper visibility of these hooks, it becomes easy for us to identify those re-rendering issues in advance, not in advance, at that point of time. The next is context. So as part of yesterday's session, actually, we got a quick review about what context is. So when exactly are we using context? Yeah, exactly. So to provide prop drilling. But the problem with context is context flooding can happen. So actually, React DevTools helps us to identify those scenarios as well. Now going forward, actually, I want to talk about a tool that we uses to the least, or it is very underused tool, which is provided by React DevTools. Any guesses? Actually, it helps us to do performance analysis. Yeah, exactly. So how many of you are using profiler? I would say 10%. OK. So basically, we have to make use of profiling to make sure that the re-renders that happen in our application is as expected. So can you see on top, actually, we are seeing the 12 number, 4 out of 12. That's actually the number of re-render that happened because of one action that we carried out in our application. And we'll get what exactly caused that particular re-render, or the time taken for each re-render. Then the component by division, like what time exactly was taken by each component in a re-render. All those things we can identify. So make sure you check out all those features. And actually, after every fix, we have to make sure that the app is working as expected. We are not having any unwanted re-renders done. Okay. So given that we have all these tools and features given to us, the problem is React DevTool is actually just giving you a visualization, like a representation. It's us who have to identify what went wrong. So, okay. So basically, there are some gaps that DevTools leaves behind, which we can make use of AI to fill. First is context gap. As I mentioned with React DevTools, we are getting the current UI state, but not the trail of events that led to a bug, or not the session replays, or the network payload trail, or anything. We won't be able to get it with React DevTools. So there are tools which helps us to identify that. So with AI, we can actually do the context reconstruction. So we will be able to get the proper session replays or the events that led to that problem, and also the network payload and everything. There are tools for that. I'll introduce some of the tools to you later. The next one is root cause blindness. So once we identify the issue, like once we spot the issue, we have to find the root cause. And it takes a lot of time to pinpoint that particular cause that's causing the issue. Can I get some of the commonly found issues, the commonly found root causes that we face on a daily, not a daily basis, but mostly? I'll give you a start. As someone mentioned, prop drilling is one thing. Then something else. Okay. So context flooding, as I mentioned, also hooks misuse. All those things can be reason why we are getting an issue. So the reason we are able to mention these parameters or these root causes may be because of our experience or the intensity in which we are getting these issues. But imagine we are getting a bug because of a rare scenario. So it eats most of our time from a work week. And with the help of AI, we can actually recognize the pattern. AI will help you find the root cause. And some AI tools actually give you patches which you can test it against your code base. But make sure you review the patch that you're getting. Never blindly go with the the solution that you're getting. Because the AI model that we have right now is not that advanced, which we can blindly trust in case of code. Next one is reactive debugging. So basically, the debugging workflow that we follow today is actually, we wait for something to break. And once something is broken, we'll go hunt to find out what exactly went wrong. So basically, I know it's a strong term, but it's like a postmortem. So with the help of DevTools, we are not able to identify any issues that might happen in future, or the future bottlenecks or performance issues. With the help of AI, we can move our reactive debugging to predictive debugging. There are tools which is learning upon millions of repositories, AI/ML models, which helps us to identify these logical errors in advance. So it becomes easy for us to identify those issues and also reduce the number of bugs that is happening on our application in advance. Okay, that will help us to reduce the production bugs to a greater level. I know that's kind of a dream for at least 90% of us developers. So let's go with the options that are already available today. So now coming to context reconstruction. So I mentioned we'll be getting session replays and then event stack trace and everything. So it's not just these three tools. There are multiple other options too. I'm just giving you some examples. Now, Zippy AI, Highlight IO, LogRocket, all these platforms actually gives you proper session replays of the error, and also the user interaction, what all interaction the user made at that point. Then some insights can be obtained from those applications. The one thing we have to notice, all these platforms actually have free tier for them, but Zippy AI and LogRocket minimizes the features that we get in the free version is minimum. Whereas Highlight IO, it's a bit much, but I'll just give you a quick walkthrough through two of these applications. And Zippy AI and LogRocket we can integrate only if we have a proper domain, whereas Highlight IO we can do it in our localhost as well. That's the major difference. Next is pattern recognition. So these are the Interfix, GetAfix, or RepairNator. These are the platforms that we can make use of to identify the root cause. And they will actually propose a solution to us, which we can test it against our code base. Next is, predictive debugging. So these were the AI ML platforms that I mentioned, which will actually give us predictive debugging, which will actually give us future bottlenecks in advance. They actually can identify these issues because they are learning upon millions of repositories. Now going through only two of these platforms because of time delay, I will say time constraint. So I'll go with Highlight IO first. Basically, one second. So this platform actually, I have integrated this platform to one of our in-house product. It's Tribe. We basically use it for employee engagement programs. Like we can post contents to it, just like how we do it for Instagram, but internally. And there are options for us to create surveys. The admin can create surveys for the employees. So one of my colleagues actually got a bug in it. He was unable to generate content with AI, but I was not able to reproduce that. So since I got a proper recording from this application, and I'm repeating it, I'm not an advocate of this application, but any replay application, I'll be getting a proper session replay, and with that, actually, I was able to identify where exactly went wrong. So this, you can see, here, we'll get the past sessions as well as the current session. So this is the application that you're seeing here. And I'll get the proper session replay. And each timestamp will give you what all happened at that point, like user click, and you'll get a proper event list there. And you can create AI insight, like what exactly happened in the particular session. I can create an AI summary out of it. So the major difference between this platform, Highlight IO and Zippy or LogRocket, is that we are getting the entire session. Like from the moment user logs in till the session is over, I'm getting the entire session in this platform. Whereas Zippy and LogRocket gives us the particular error session, like error snippet, just the error snippet. So it's easy for us to identify that particular position. So with this, actually, we have to watch the entire session to identify where exactly went wrong and all. Yeah, so we can actually integrate the same with our Slack, and also it's easy for us to get updates if something went wrong and all. And in this application, actually, we can integrate this with our backend too to identify bugs from backend. Now, the next one is Zippy AI. This one is somewhat similar. They'll give you dashboards regarding the intensity of bugs that's reported in your application, whether it is front-end or the network error. And as I mentioned, some of the features that they're providing is limited. I won't be able to show you all. So we get session replays too, and heat maps, which helps you identify where exactly the user is spending more time on. This actually comes in use if you're using an e-commerce platform, or which includes direct communication with the clients and all. And then about API performance, we will be able to identify if we are facing latency in API, or what's the percentage of errors that we're getting from API. All those values we'll be able to identify with this. So, the other platforms, make sure you explore it on your own. And now I'm moving on. Yeah. So can someone identify these logos? Yeah, CodeRabbit is CodeRabbit, Cursor, Copilot. So these are mainly agents. Windsor. So these are mainly agents. I think these are some of the underused one, or it's not that common. Ask Cody, Kyoto and all. There are certain other agents too. So we make use of these agents basically for refactoring or for code suggestions or to get suggestions about how we can implement a certain feature or something. But actually, since these agents have complete context of our whole repository, they are actually like a background validator. They will give us solutions for any bugs that we face. But always make sure, even though they have context, they never assume that they know your runtime conditions. Make sure you give them context regarding that too. Okay? So these are certain agents, and there are multiple other agents which are available today. Because of space constraint, I couldn't include more. So in the beginning of the session, what I mentioned to you was we can combine React DevTools with AI so that we can create a smarter debugging workflow. Let's see if we achieve that. So DevTool is capturing the fiber level truth. So that's the fiber level truth that we're using now. With the help of AI, we are able to interpret what that behavior meant, what we are seeing, what that meant. So before, developer was just getting a visibility. But with the help of AI, he's getting a proper diagnosis. Over time, we can, by combining this DevTools with AI, we can create a prediction and prevention model. So DevTools was basically reactive. We can convert it to proactive and latent predictive. And at some point, or we can make use of that right now also, it will be a self-healing platform. With the help of DevTools with AI, as they are giving us patches for our bug fixes and all, we can make it a self-healing platform. So before winding up my session, let's just analyze a simple scenario. So I'm having an e-commerce platform, which is a mid-size e-commerce platform, and there is about 15 React developers, of which they're using React 18, the latest version of React, with a bit of Next.js and TypeScript. So the major problem that we're facing is they had to spend about 20 to 30 hours per week for debugging. So analyzing it further, let's say I'm not going with the maximum amount, like 6 hours is not I'm taking. Let's say their debugging time is 4.2 hours. Since there is about 15 developers, on total they were spending about 20 to 30 hours per week. So do we like to spend that much time just for debugging? Right? So dev satisfaction is very low. On adding AI, the debugging time will be reduced was reduced to 1.8 hours, which is a considerable reduction in the time. So because of that, the total hours spent weekly was reduced to below 10 or just 10 hours. And of course, self-explanatory, our dev satisfaction will increase because we get more time to develop more features. The production bugs that we are getting, there is a reduction in production bugs that we are getting. So basically, dev satisfaction increases very much, I would say. So I hope this session was useful to all you guys. Thank you for the patience, and yeah. So what? Yeah, so if you guys want to connect with me, you can use LinkedIn. And I'll be here in case of any discussion, or if you just want to connect, you can approach me. Thank you.
Round of applause for Aarathy.
React India.